So for DNA replication, the helicase enzyme is going to unzip the DNA genetic code. As the DNA is being unzipped, the leading strand is going to building the complementary nucleotide base pairs, and that's going to happen continuously. So as the DNA is unzipped, this side, the leading strand is being built. On the opposite side, the lagging strand, a primer is going to be laid down by the primase enzyme, which is going to indicate where the DNA polymerase should begin. And that is when there's complementary base pairs are going to start and be built. The next section is going to have a primase laid on a primer, and that indicates where the polymerase is going to build the next section. These sections of nucleotides that are being built by the polymerase are called Okazaki fragments. To connect the Okazaki fragments, you have a ligase enzyme which is going to replace the primer with the actual nucleotide that should go there. So you have an entire sequence. In the end, you will end up with two identical DNA, identical to the original and identical to each other. First, the helicase enzyme is going to unzip the DNA. The DNA is going to the RNA polymerase. The RNA polymerase is going to match up the mRNA pieces and start to build an mRNA chain. This side is your non-coding strand, your template, that actually matches with the mRNA. The other side is your coding strand, which is actually what is built. It is AUGC. The only difference is that instead of T, you have U's for RMNA. The part of the RMNA is useless stuff. Those are called introns that have to stay inside of the nucleus because this is taking place in the nucleus. And the useful ones are going to be exons that are allowed to exit or leave the nucleus. The connection is made. This process is going to continue on where you have amino acids that are going to start connecting together, and you have tRNAs that are going to be leaving. When those tRNAs leave, they are recyclable, so they're going to pick up another amino acid and bring it back. And the amino acids are going to be chained up, continuing to be chained up again and again and again until a stop codon comes along. The stop codon is going to cut off your amino acid chain, which is now going to be curling up into a polypeptide that is going to be showing up as a particular gene expression. The entire process is the central dogma. Central dogma says that you go from DNA to RNA to protein. The codon is going to match up with tRNA's anti-codon.